All right, guys, slide 5, we're now going to start drawing things. So here, number 1, I've done all these. 5,5-dimethyl-3-octene. Okay, so we have oct, so we know we need 8. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. We have our 8 carbons in a row. Now we can start filling in, all right? Here, 5,5-dimethyl, we are going to start counting from the left because this 3-octene means that the double bond is on the third carbon, and we have to start counting closest to the double bond. So 1, 2, 3, double bond, 4, 5, and there's 2 methyl groups on number 5 right there. All right, 3-methyl-1-octene. So 8 carbons in a row, 1 octene. So there's our double bond off number 1, and the third one has a methyl group. So something that looks like that. This is a little bit convoluted here for number 3. 3,5-diethyl-2-methyl-3-heptene. That's a mouthful. Hept, that's 7. So we made a 7-carbon chain, and I put the double bond on carbon number 3, which is right there. All right. And so now on carbon number 2, there should be a methyl group. On carbon number 3 and 5, there should be ethyl groups. So we have something like that. Here we have pentadiene. You should be able to do that. And the rest of them, I'm going to let you look over instead of walking through each of them. I think you can handle it. All right. Cis-trans isomerization. Isomers are different ways a group of atoms can be connected, as you can read. All right. The only difference is going to be where things are placed, but the connectivity is going to be the same. Cis-trans isomers occur only in alkenes because atoms cannot rotate. This is only alkenes. All right. So two major groups either on the same or opposite side of a double bond. All right. So here I've done these examples. Cis-2-octene. Cis means the two major groups, pretty much meaning not hydrogen, are on the same side. Trans means they're on opposite sides. If you've ever heard of trans fats, that means you have a trans double bond in there. All right. So here, cis-2-octene, what that means is a double bond here starts on carbon number 2. We can see that. Cis means that this methyl group, or this 1 carbon, and these 5 carbons, 2, 3, 4, 5, are on the same side. Trans 3-hexene means that these two groups coming off the double bond are on opposite sides. So you could see trans 3-hexene and then trans 4-methylpentene. All right. This is what we have here. This is something that we're going to have to deal with because cis and trans isomers change chemical behavior. All right. And this is one of the things that we can look at if we look at slide number 7. Cisplatin is a chemotherapy drug. It's used on a large number of cancers. It's administered through an IV. I mean, these are all things you can look up quickly. When you have this, it can give problems with, or give you kidney problems. So you have to have extra fluids when you have it. However, this cisplatin, it's got this platinum atom here. And cis means, see this NH3 group and this NH3 group, they're on the same side. And these chlorines are on the same side. There's something called transplatinum. That doesn't do anything. It just, you ingest it and then you flush it out of your system. And so this is where cis and trans isomers play a large role in what's happening. All right. So here we go. Stereoisomers versus constitutional isomers. All right. Constitutional means that things are bonded in a different order. Stereo means they're bonded to the same atom, but we have a different way of orienting. So here, ethanol versus dimethyl ether, we talked about that. That's constitutional, right? Way back when. But now we could start talking about stereoisomers. 1-butene, cis-2-butene, trans-2-butene, all right? These are all stereoisomers because the atoms are connected in the same order. But what we're starting, well, excuse me, 1-butene and cis and trans-butene are constitutional isomers. Cis and trans are going to be stereoisomers, excuse me, because the same order, same way things are connected. Here we have a double bond and then single-single, all right? This is 1-butene. Cis-2-butene and trans-2-butene, these are going to be stereoisomers because in this case, both the CH3 groups are on the same side, whereas in the trans one, the CH3 groups are on opposite sides.